Here's your note packet. We'll do them both today. They're pretty much. All right. So then some of this is going to be, and you have 2 kidneys. They're towards your back. There's a waste in that blood. So you can see here in this diagram, you have your blood supply and these arteries and waste products from our blood. 2 kidneys, kidney valve. If somebody has damage to one of their kidneys, but the other is working, they could still survive in that other kidney that's. And so if neither kidney is working, that's a bad situation. And so a person whose both kidneys are not working has to go to the hospital every single day for what's called dialysis. And in dialysis, they hook a person up to this machine that basically filters their blood artificially. And they can do that for a while, which you have to go every single day as your actual kidneys, but it can keep you alive for a while until you're able to get what? Right, a kidney transplant. So in the kidney transplant, they take a kidney from another person and put it into your body, replacing your kidneys that weren't working. You can donate it. You could donate a kidney if it's a good match. You could donate a kidney to them, and you could live fine with a single kidney, and they could live fine with your healthy kidney. And so that's something that happens.
Do they have to match like blood types?
Yeah, they match blood types and other things. Yeah, they usually have to match them very carefully. So your body, because the more close the match is, the less likely that the other person will reject that kidney or their out of our blood and produce urine. And then the urine that they produce sort of drips down through a tube called the ureter. The ureter basically carries this urine from the kidneys down to the bladder. And the kidneys produce urine constantly. There's a constant drip of urine through the ureter. All this urine collects in what we call the urinary bladder. So the urinary bladder basically stores up this urine. Otherwise, if you didn't have a urinary bladder, then there'd just be a constant drip of urine out of our bodies, and that wouldn't be very good. But the urinary bladder stores up this urine until it reaches a certain level, and that triggers the urge somebody has to go to the bathroom. So the bladder. And then once it is ready to be eliminated, it travels from the bladder out another tube called the urethra, which carries that urine from the bladder out of the body. Kidneys, ureter, bladder, urethra is the order that urine travels. If you look at how the kidney is set up, this is like a cross section if you were to look into the kidney. You have a supply of blood going in, sort of looping around inside the kidney. Along the way, the waste products are removed, and they're sent into these little yellowish organs and then out through the ureter. Then that blood, after it's been cleaned, travels back into the circulatory system through these veins. So kidneys work by taking in blood that has waste in it. That waste comes from the cells of our body. Takes that in, filters it, producing urine, getting rid of that bad stuff, and then that clean blood goes back into circulation. So that's what urine is, basically water. So the person was dying of thirst in the desert. Could they drink their own urine?
Oh, yeah. I know what you have to do. I saw this on TV before. I know what you have to do.
What?
You have to get like plastic wrap or something and let it dry up, and then the water comes up.
Okay. Yeah, so urine still contains, so you couldn't do this indefinitely. If you just were to drink the urine,
you'd die.
Well, you wouldn't die probably the first time you drank it, you wouldn't die, because, so the urine contains poisons and toxins. So if you drink it again, your kidneys are going to have to work even harder to get rid of all of that again. So no, you couldn't actually, unless you were somehow able to filter it or evaporate the water from it, conserving it.
How would you do that?
You could boil your urine, capture the evaporating water, and if you collected that, that's just pure water. And then what would be left in the pan you're boiling your urine in would be all the waste salts and stuff. Same way you could do the same thing with seawater. You know, you can't drink seawater. It just dehydrates you even more. We talked about that with osmosis, but if you boil it, only the water evaporates. The salt is left in the pan. If you can capture that evaporated water, that. Alright, and if you do, you have needed things for your survival. So when you write the story, well, you could have like a plastic or a coat over it, and you put a rock in the middle, so as this water is evaporated, it comes down, it collects on the underside, drips down, and then this is the... Yeah. It doesn't matter if it's hot or not, it's water. But eventually that water is going to be reduced, because then you're going to have less and less water available. Alright, anyway, let's move on from boiling urine. So, two other organs that are considered excretory organs, the skin and the lungs. So your skin has sweat glands, which are considered an excretory organ because they get rid of waste heat. And so why do we sweat? What's one of the reasons that we sweat? Removes heat from your body, cooling you down. It's why it's cold when you come out of the pool and there's a breeze out. Or when you get out of the shower, you're cold because you have water on your skin that's evaporating, and that cools you down. That's how sweat works. The sweat, as it evaporates from your body, cools you down a little bit. But what's left over after the sweat evaporates? You smell bad because if you've been outside all day playing sports or running, you may be left like white, crusty stuff on you in your baseball hat that you sweat in all the time. Oh yeah. Yeah, that white stain. Like it's salt. It's the salt that your body releases from your sweat glands. It's also why sweat that goes into your eyes, it burns your eyes, it tastes salty. It's because it has these salts in it that were delicious. If you're running, yeah, you run the Boilermaker, sweat goes in your mouth eventually. You're an athlete, you don't sweat? That's not healthy either. And this is going to overlap a lot with our next body system, so I'm not going to talk much about it, but excretory system. Let's move on. The respiratory system is our body's way of taking in oxygen and removing carbon dioxide. So we need oxygen in all of our cells. Every cell. They need it for what process?
Respiration.
Respiration, which happens in which organelle? Mitochondria. To release energy that our cells need to live. So we need a constant source of oxygen. We get that by breathing. We also, as you know, what gas is produced by breathing helps us to remove carbon dioxide and take in. Yeah, you are, but sometimes if your blood pH actually helps you. So the diaphragm is the muscle that allows us to breathe in and out. Your diaphragm is sort of a sheet-like muscle, and it's tucked into your rib cage. It stretches across the whole bottom of your rib cage. If you look in this diagram, it's sort of inside here. If you could remove an umbrella-shaped muscle, and it's attached and it seals off. It lowers the pressure in your chest, and it inflates your lungs with air from the outside. And so your diaphragm allows you to breathe in, and then when it relaxes, then you exhale. Now sometimes your diaphragm has a sudden spasm causing you to make that sound, causing it to build up pressure in your chest. Other times, your diaphragm can be temporarily disabled. With a soccer ball.
Knock the wind out.
That's what we call getting the wind knocked out of you. You get hit, and you suddenly are unable to breathe. Your diaphragm stops working for a few seconds, and you feel like you can't breathe. It recovers pretty quickly, and you can breathe, but that's what getting the wind knocked out of you. What's that? No, it just happens. No.
What about a girl who ends up for like
What, hiccups? Yeah, every once in a while people get like extreme cases of hiccups. I always get hiccups when I eat spicy food. I always get hiccups. Into your lungs, where it branches into two sides. Those bronchi branch smaller and smaller to form your lungs. On the bottom is the diaphragm. All right, I know some of you are squeamish, don't like growth. All right, so breathing, I'll tell you when it's gone. Your lungs taking air in. Respiration is the process of actually using that oxygen in ourselves. In our atmosphere is mostly nitrogen. So about 79%, 78% of the air is nitrogen. We don't use it in breathing in. We breathe in 79% nitrogen, we exhale the same amount. Our bodies don't use it from our lungs. But the air we breathe in is about 21% oxygen and even less than 1% carbon dioxide. These are like rounded. With that air, what about the air you exhale? How is the oxygen different, you think? No?
Wow. The same.
Why would there be less? 1% oxygen. Some of that oxygen then goes into your blood cells. So when you exhale, there's only about 6 release that carbon dioxide, and when you it is contained. Hearing yawning. Scientists don't really. What's that?
I know.
I don't know.
I know.
All right, we need to finish this up. Which is better to breathe in through?
Mouth.
No.
Your nose. Your nose is better for a few reasons. First, it warms the air before it gets into your lungs. It has a longer passage, it goes through your head. You have hairs, things in the air to trap all that junk in the air so that it doesn't get into your throat, sort of. Back here is where those two pathways merge.
Feel it. Like with your tongue, like if you go like,
Okay. After that air goes through that trachea, which is trachea, you can see here has these rings around it, these rings of cartilage. They help reinforce it, make sure it's strong, because if your trachea is damaged or collapses, that's a dangerous situation because you can't then get air into your lungs. You get air into your lungs, then you can't live.
Then you die.
Every once in a while, somebody gets a block off part in the front of your neck.
Oh, it's not for the people that smoke.
So they can, hold on, they can cut into that, into your trachea, and then you can get oxygen in through there if it's, there's a little hole there. You have to hold that little speaker up to their throat to pick up the vibrations. They went down through his mouth? Yeah, and sometimes, oh, I can make an incision there, that's it, yeah. So the trachea is the main passageway into your lungs. It's a big, thick tube. Then it branches off into the bronchi, and then it branches over and over again, like a tree, getting smaller and smaller. And eventually it ends in these things called alveoli. Not ravioli, but alveoli. And alveoli are diffusion happens. That's where oxygen diffuses into the blood and carbon dioxide diffuses out.
wait, how do you eat? What if you put it in your mouth and it just comes out?
No, because remember, this is not the same as your treatment. All right, last slide before we are done. These alveoli look like this. These little clusters of grapes surrounded by blood vessels. As blood goes around those, it takes in oxygen and releases carbon dioxide.
Dude, it's a horsey.
Nick,
How long does it go?
I mean, over a minute and a half.
That's how long to do that throat surgery for?
Which throat surgery?
The pipe one.
No, and that's usually like an emergency tracheotomy is if you have something lodged in your throat and they can't remove it, then they might do that. I don't